Alright, so we are trying out this problem called number of closed islands. So we're given a 2D grid. It's either 1 or 0. 1 is water, 0 is land. And there's a definition of island and there's a definition of closed or totally a closed island, right? So an island is just a maximal 4 directionally connected group of zeros. So for example, all the zeros together, this is one island, this is another island, this zero is another island, this zero is another island. Or the complete connected land is one island. And uh, a closed island is an island which is surrounded by ones all left, top, right, bottom. So for this island, top, bottom, left, and right is all connected by uh, basically the boundary, not the inner boundary, but the outer boundary. So for example, for this again, the outer boundary is all water. For this, the right side, top side, no water, right? So that's why these edges are don't get considered. Okay. So first, if we can identify all the islands, that itself might. So one thing that's quite clear is obviously that the island that we're talking about would not start from the edge of the array, right? All the edge is something that we can just remove or ignore, and then we're trying to find out um, simply how do you define an island. So for each cell, we look at its all the four neighbors and top, right, left, bottom, and we connect to that cell to so from every cell you can go to top, left, top. I mean the four directions you can go to, and from each direction you basically check if it's a let's say I have to find out the number of islands. Let's say that's the first question I want to solve, right? How would I even solve for number of islands? So that would mean that I would be interested in all the zeros. All the ones I'll just ignore. So I'll go from here. Let's say I go from left, right, bottom, and then I'll also mark a visited array, right? Okay, so I go from here, and I look at this guy. So this will be one connected component. So I'll give this guy's connected component as a value. And I'll come to this zero, and I'll see that both the basically for every guy I look at its top and left, and I'll see it's not a zero, so I'll give it another value. It will get the same value, it will get the same value, it will get the same value. It's a one, so it will break. It will get the same value as this, and then it will get the same value as this. So I'll get to know the number of islands based on the number of particles. Okay, so that I think I can find out. Now the question would then be number of closed islands. How do you find them? So there's one thing to check, which would be, hey, is this a boundary of an island? And if this is a boundary of an island, then you can also sort of add it to the fact that this connected component is a total island so far or not, right? We'll assume the best and we'll assume that everything is a total island, and then if it does not become total island, then we'll make it as false. So for example, here 0. Now we'll give it call of a total island. So this is a new connoted component, and this is the how do you know if something is a boundary? So I want to get an example where something is not a connected component. Something is not a, like, that's how you will be an island, right? Otherwise, you will be some island on the edge. Like, can there be an example where, you know, so a closed island is basically an island which is not in the edge, right? That's all. I guess so, right? Yeah. So now, only that you need to solve for is for a connected component. If you get an item on the edge, then you mark that as a um, you mark it as a edge island or an inner island, right? That's a two. Or okay. So now I start. Let's say first thing I'm gonna do is for int I equals to 0, I is less than grid dot length I plus plus. For int j equals to 0, j is less than grid 0 dot length j plus. I'm looping through each and every element, and before that I'm also going to um, make something called as connected component. And what that means is I'm going to define an O of n size. Now the question is, can I, because it's 0 and 1, I could give a, like, I could maybe reuse the array. So one will remain null, any 0 will get a value starting from 2. Okay, I'll try that. And then okay, so there will be one case where your it will be the first row. That means you can't look at the top. That means you can only look at the bottom. I mean, we just do this now. If there is a problem, which is, okay. So when as soon as you find somebody which is water, you have to make its four neighbors as also water, or basically the four neighbors which are water. give the same connected component. So if grid of ij is 0, I think for now, for simplicity, let's define another array, right? So integer array, call it connected components. Let's say and I think it's initialized for 0 only, so that is fine. So now if you so if I encounter a water, this is water, then if it does not have a so firstly if this connected component is not given, then you give it a connected component as this island number, right? Now what you have to do is when you become water, so when and if your right your this guy's top and this guy's left is already being looked at. So only thing that's not being looked at is this guy's right and this guy's bottom. So right and bottom is where you add. So for right you have to check if right is I plus 1, right is j plus 1. So you do this and you also do the row I plus 1 row is less than grid dot length, and you give cc of I j equals to right. So basically when I get to the 0, I'll give this with my first island, and I'll give the same island number value to this guy as well. When I come to this guy, I'll give it island number 2, and this also will get island number 2. When I come here, I'll give this island number 2, this also island number 2, this also island number 2 if they are 1. So if this, then I have to do one more thing, and grid of I j plus 1 to 0. Right, so all of these will get this eventually will all of these will end up getting the same value, because okay, this when I do this and this will get the same value, and this when I come to here this will get the same value, when I come to here, okay, when I come to here this will get the same value, okay, when I come here It will already have the same value when I come here. It will already have the value when I come here. It will already have the value. Yeah, from either this or that. Now that's another thing. Yeah, I think I trust you, right? So you get all these values now. So you know the number of islands are simply island numbers. Now you have to also find out whether an island is an inside island or an out or an edge island on the edge or not. So for example, when I come here, I wouldn't know, but if it continues till zero all the way, uh, so then what you have to do is maintain a map of island number, like a map. And this value is what exactly? So Boolean. So you get this map, and the idea for this map is whenever you get any item which is water and is on the edge, so this is basically a water guy, and it's already got its connected component. Now, if I equals to 0 or j equals to 0 or I is equals to width dot length, j equals to 0 dot length minus 1. So you know if this island is not at is at the coming to a boundary, coming at the edge, then uh, uh, the island number comma false. Or simply just a set, maintain a set, yeah. And so one thing that you have to now do is the number of islands that you've got. Minus Okay, let's see if this works. And at least for the first example it works. Let's try a second example. Basically all examples rather. Load. Okay, submit. Okay, we got a wrong answer here. Let us see. This is the input. And our output was 2, but expected is only 1. Okay, so this will be an island on the edge, this will be an island on the edge, this will be an island again on the edge, this will be an island on the edge, this will be an island which is completely like is it? Yeah, I mean it is so this is the top. On the left side there is water, on the right bottom there is water, on the right side there is water. So this 0 has to be the island number. So okay, let's try out the number of islands. I'm guessing maybe the number of, so here number of islands is 1 2 3 4 5, and 4 of them are edge islands. Let's see where we messed up. So this is the test case, and we let's say out are we counting more islands? Are we counting less edge islands? What's the deal? So 6 and 4. So 4 is correct. So 6 is wrong. We're somehow counting uh, more islands than there are. So let's see again. When we do count this, it will be as counted as one island. So I think basically these somehow are getting counted as 2, right? So should we print out the CC array? Okay. 0 is less than. Okay, let's see. So this is how our setup is. 1, 2, 5, and 6 was completely fine. This we started with, we gave this 3, we gave this 3, and then when we reached, because this was 1, because this guy we thought is a different guy. So this is where that union find didn't, we actually have to use the correct way of doing the union find here. This is a typical example of a union find where Basically, basically this guy, when he tried to set it as 4, so basically this would be set as 4, and when this guy is trying to set this guy's value, uh, you have to combine and do those two are together. How do you combine is the question. I mean, one way obviously is you can first create a graph out of this array. But I mean, it isn't this already sort of like a graph? Okay, if you say so, so you're saying it's already a graph, then excuse me. I mean, because all the information about who my neighbor is, whom I am connected to, is already available. That is true. So you start from, yeah, you go through each and every node. That is also fine. This is what we did. We went through each and every node. Necessarily didn't have to go through each and every node. If a node is already visited, then you don't visit it. Is it? Is it? If you do, if you do DFS, so meaning you find one water, and using that one water, you find all other waters. Okay, so let's try that. So in that case, the way that you do is you find this water, try to find go to any other waters. You don't find any other water, then you find next water. This is my next water, and so okay, I try and go and find all my waters. Okay, and when you say try and go to all my waters, it not the ones that have been visited, and the ones that have been visited would just be already having a non-zero value. Correct. So when I come to this 0, I will go to this 0, and from this 0 I will go to this 0, from this 0 I will go to this, from this I will go to this, from this I will go to this. So you go in all the 4 directions using DFS and find and make the connected components. I can try that. I can do that. So not much of a difference here. You're going to each and every cell, and let's say here you call just call DFS ij with grid and CC, or grid CC and too many. Hmm, let make let's make these two as static. I want to see whether even static is needed or not. So if I don't make it static, then these are what objects, variables, but all is defined as a null or whatever. And then in this function is where I'll define them. So I guess I don't even have to define them, right? So maybe I can initialize them again. So I can do, and I can do, and so maybe then I remove just the initializations. Now this and this is fine. So I do DFS, this, and you probably so grid is there, and that is it, right? And then eventually you'll do okay. I can push all of that. So Control X. And this is sort of done. Now I do private to DFS, and I'm calling DFS with something like this. Okay. Now, first thing obviously you're going to check is the grid equal to 0? Before that, the first thing you're going to check is and it's not visit, and it already does not have a connected component. Okay. So then you're interested. And now you're interested because now you have to give it a, so there is no if here. So now this is that you have to do. There is a problem. What's the problem? So the problem is you have to go left, right, top, bottom, and you have to assign them the same CC, and you have to so going through each of the items. So when you're calling DFS, first thing that you have to do is yes, you're only interested if it is 0 and its thing is not set. 2 0, but you have to go in all 4 directions. Now that's my question, why do I have to go in all 4 directions? But yeah, because you have to, right? Okay, so we go in all 4 directions and I call DFS again. Then where do I, is this something, what's, you know what to do, right? Yeah, okay, so uh, basically, so let's change some shit here. So this, if your if this is the case, then you do just other. Basically, if you find something new, then your num or island number, just do this island number plus plus. That's all, and you do dfs I j and grid, right? So now, if you have come here, that means you don't have to check this. Okay, maybe still check this, and you set ccfij equals to island number. Okay, but you have to go to its four neighbors. There is no not going to the neighbors, right? So one thing that you want to handle probably is if out of grid it's handled here. So if it's less than 0, j less than 0, then equals to return. Otherwise, if DFS is called, you're only interested in uh, and the current component. Now this current component will go and go through all the branching and whatnot, and just so we are only interested in adding the connected component if it's not already set, right? So if grid is 0 and connected component is 0, so we now have to set the connected component. So we set the connected component, and if this guy who is 0 grid and his connected component is also not set, is it on an island, then we set it on the island. And then we also want to go to all its neighbors, right? So then you just do dfs of I plus 1 j grid, dfs of I j plus 1 grid, dfs of I minus 1 j grid, and so I j minus 1 grid. So you have done dfs and you get to all each and every individual thing, and it will either mark the island number or it will either mark the okay. Now run code. Compilation error. Cannot find symbol cc. Okay, so pass cc everywhere then. uh, okay, you got the wrong output. Everybody gets 0. Okay, why is everybody getting 0? uh, so we do island number plus plus. This has to be done here. Okay, Yeah, okay, it matches. Stop the prints. All right.